Caterpillar's dozer lineup isn't a ladder where bigger is always better. It's a spectrum, each machine purpose-built for a specific class of problem. We're going from under 20,000 pounds all the way to 248,500. From a machine you can tow with a pickup truck to one that requires you to legally dismantle it before moving it down the highway. Let's start at the bottom. Level 1. The D1 and D2, the driveway specialists. The D1 and D2 sit under 20,000 pounds. That's the magic number. Drop below it, and you bypass heavy haul permits entirely. These machines load onto a standard gooseneck trailer. No special routing, no state permits, no convoy. You just drive them where you need them. But Caterpillar didn't just shrink the machine, they re-engineered the heart of it. The old 4.4-liter engine was dropped for a compact 3.6-liter block. Smaller displacement, same horsepower, same push force, fewer emissions. That's not a downgrade. That's a decade of engineering packed into a smaller box. These machines grade driveways, clear residential lots, clean up around utility lines. Precision work in tight places. The key word at this level is accessibility. Go where the big machines simply cannot. Level 2. The D3, the Finesse King. Step up to the D3 and Caterpillar introduces you to something you won't find anywhere else at this scale. Blade shake technology. Here's what that means. Clay and wet mud don't just sit on a blade, they cling. On a traditional dozer, operators stop, get off, and manually scrape the blade clean. On the D3, they press a button. The hydraulic system vibrates the blade at a high frequency, shaking caked material loose without stopping the machine. It sounds like a small detail. On a muddy job site, it's the difference between hours lost and hours gained. And the D3's blade isn't just clean, it's intelligent. The variable pitch angle tilt blade, VPAT, connects to onboard computers. The system automatically tilts and adjusts blade depth in real time to hold a perfectly flat grade surface. The machine is doing the math that used to require a skilled operator, years of experience, and a lot of expensive mistakes. So here's a question worth sitting with. If the D3 is already this sophisticated, what does the Caterpillar add at the next level? Level 3. The D4 and D5, the Goldilocks scale. The D4 and D5 occupy the zone between compact utility and full industrial, what engineers actually call the Goldilocks range. Not so small you're fighting capacity, not so large you're fighting logistics. Caterpillar even simplified the naming system at this level. The older generation carried designations like D6K2 or D6N, letters, suffixes, fine print. The current generation dropped all of it. Clean numbers, cleaner branding. But the real engineering story here is the D5's weight distribution layout. Most dozers lose traction on steep, saturated slopes. The D5 was specifically engineered to push heavy loads straight up a 2-to-1 mud slope without sliding backwards. That's a 50% grade. The weight distribution across the undercarriage was calculated to keep the machine moving forward, not drifting, not stopping, on terrain that defeats other machines entirely. This is the level where CAT starts solving problems that aren't just about power, they're about physics. Level 4. The D6 and D7, the high drive revolution. The D6XE changed everything. It carries the world's first high drive electric powertrain in its equipment class. Let that land for a moment. There is no traditional mechanical transmission in this machine. The diesel engine powers a massive electric generator. That generator sends electric torque directly to the tracks. The result? 35% more fuel efficiency than a conventional drivetrain. Not 5%, not 10%, 35%. Why does this matter on a construction site? Because these machines run 8, 10, 12 hours a day. A 35% fuel reduction across a fleet is the difference between profit and loss on a long-term contract. Now here's where the D7 solves a different problem entirely. Tight turns under full load are where old crawlers bleed power. The standard differential drops torque to the inside track during a turn, and you feel it. The machine slows, the load lifts, momentum dies. The D7's liquid-cooled differential steering system eliminates that completely. Both tracks remain full power throughout every turn, no matter how tight, no matter how loaded. You don't just steer the machine, you command it. We're halfway through the levels. These machines from here get heavier, more specialized, and significantly more expensive to move. If you're new here, subscribe. We go this deep on every machine. Level 5, the D8 and D9, the heavy Blockbusters. The D9 GC crosses 100,000 pounds. That's 50 tons of steel, hydraulics, and horsepower. Over 400 of it, moving across terrain that would destroy a lighter machine in hours. At this weight, the ground itself becomes a weapon. Granite job sites are full of sharp, jagged rock faces that don't care about paint. They care about your engine oil pan. The D9 G6 addresses this directly. Caterpillar installs a sacrificial steel belly guard plate. It absorbs the impacts. It slides over the jagged edges. When it gets destroyed, you replace the plate, not the engine. But here's where the D9's size creates a different problem entirely: moving it. These machines are rarely transported in one piece. The D9 on a highway typically means splitting the blade and push arms from the main tractor chassis just to comply with weight restrictions. 2 loads, 2 routes, twice the logistics. That's not a flaw in the design. That's the trade-off you accept when you buy a machine this capable. And mining companies make that trade-off willingly. Level 6, the D10, the shape shifter. 1977, Caterpillar releases the D10, and the industry has never looked the same since. The D10 was the first machine to debut Caterpillar's iconic high-drive elevated sprocket design. Instead of a flat track layout, the drive gears sit elevated, lifting the drivetrain into a triangular configuration. This does something previous designs couldn't. It takes the crushing weight of the machine completely off the drivetrain and isolates the gears from rock impacts below. Why does this matter? Because the older D9 had physically reached its limit. Mining companies needed a machine that could rip solid rock, not push loose material, not grade soft soil, rip solid rock. The flat track designs couldn't do it. Every attempted upgrade just broke the drivetrain faster. The D10 was built because the D9 kept failing, and the elevated sprocket it introduced became the standard for every large cat dozer built afterward. One design decision made in 1977 still shapes the machines built today. Level 7, the D11, the 115-ton king. 248,500 pounds, 114 tons of machine, and 850 horsepower twin-turbo V12 engine. A single oil change requires more than 25 gallons. The D11 doesn't grade, it doesn't finish, it dominates. The front blade scoops 98 cubic yards of earth in a single pass. That's roughly the volume of 3 full dump trucks moved in one sweep. But the rear attachment is where the D11 becomes something beyond a dozer. The single shank ripper, a steel claw mounted at the back, exerts hundreds of thousands of pounds of downward force into the ground. It doesn't wait for the blasting crews. It doesn't wait for explosives. It physically shreds solid coal seams and rock layers through raw mechanical force. This machine was engineered as a mechanical substitute for dynamite. Not a complement to it, a replacement. At this level, you're not buying a bulldozer, you're buying the right to reshape the geology of a mining site on your schedule without waiting for a blast window. 7 levels, 7 completely different answers to 7 completely different problems. From a 20,000-pound Finesse machine you tow behind a pickup to a 114-ton rock shredding weapon that makes dynamite optional. What Caterpillar built isn't a product line, it's a spectrum of engineered force, calibrated to match every scale of human ambition. If this breakdown was worth your time, subscribe. We do this for every machine worth understanding. And if you want to see what happens when these machines reach their absolute limit, that video is right there.